The need for an extremely complex cipher began in World War II. The Axis powers of Germany, Japan, and Italy were far outnumbered by the Allies and needed to be able to send encrypted messages back and forth in order for their attacks to be successful. This is why the Axis powers decided to use Enigma. Enigma was invented at the end of World War I by a German engineer named Arthur Scherbius, and over the years it became more and more complex. By the end of the war, there were over 150 million different possible ways to set up the cipher. Trying to guess what a message could be would be like trying to guess the outcome of 26 die rolls. The Enigma cipher is a rotary shift cipher. That means that the operator would use a machine with several rotors to encrypt a desired message. On the receiving end, the operator would be able to type the encrypted message into the machine to get the original message. The Enigma machine consists of 5 important parts: the keyboard, the plug board, 3 to 4 rotors, the reflector, and the light board. Each day, a German officer would receive a setting sheet, which would tell him what letters to connect on his plug board and in what order he needed to set his rotors for the day. At the beginning of each message, the operator would choose his own key, or which letters each rotor would start on. Most of the officers chose the same letters every time. The operator would start by typing a letter on the keyboard. The letter would then go through the plug board to its designated letter. If it is not connected to another letter on the plug board, then it remains the same. After passing through the plug board, the letter goes through each of the 3 rotors, changing to a different letter in each one according to their position. With each letter typed, the rotors shift, so that each letter is ciphered in a different way than the last. Then the letter hits the reflector, where it is sent back through the 3 rotors and again through the plug board to the light board, where the ciphered letter will light up. On the receiving end, the operator will set up their Enigma machine exactly like the senders. They will type in the encoded message and get from it the original message. The success of a rotary cipher depends on 2 things: the number of possible settings and the randomness at which those settings are chosen. The number of possible settings for Enigma was huge, but because the German officers were allowed to choose their own starting position, the settings were not chosen randomly enough. Another flaw that the Allies took advantage of was the fact that the Enigma machine would not let a letter be ciphered into itself. For example, the letter A in the original message could not be an A in the ciphered message. Therefore, you know that a letter A in a ciphered message cannot be a letter A in the original message. It must be one of the other 25 letters. This flaw led to advances in the code-breaking efforts. Enigma was finally solved by the team at Bletchley Park, a group of linguists and code breakers. They started out by deciphering the code by hand, but it was far too time-consuming and wasn't getting them very far. Finally, they came up with the means to build a machine which could quickly and effectively plug in possible settings for the Enigma machine set up that day. They would tell the machine specific words that they knew would be in the messages, words like weather or phrases like Hail Hitler, and from them the machine could figure out the daily setting for the code. This machine could be considered one of the first computers ever created. It was the breaking of this code that led to the victory of the Allies over the Axis powers in World War II. Without it, we would be living in a completely different world today.